Hi guys, let's talk about some unsolved problem in mathematics. This is about the sofa problem. Let's say we have this L-shaped corridor with a width of 1 meter. We have a sofa in this location, and we would like to move this sofa this way, round up the corner, and finally settle in this position. So the problem is, what is the shape and area of the largest sofa that can be moved through this unit width L-shaped corridor? And this was the question that was asked by mathematician Leo Moser in 1966. But until now, more than 50 years later, the problem is still unsolved. And you might be the first one to be able to solve this problem. So let's analyze this problem together. Let's say our sofa is this red square with a dimension of 1 meter by 1 meter, and therefore its area is 1 square meter. We move it this way and slide it to its final destination. There's no problem if the sofa is a 1 meter by 1 meter square. But is that the sofa with the largest possible area? Let's see. How about if we have this semicircle sofa? Its radius is 1 meter, and therefore its area is pi r squared over 2, where r is equal to 1, or 1.57 square meters. So obviously this is a bigger sofa, and let's see if we can move this around the corner. So turn around that way, and here we go. We are able to move the sofa to its desired destination. So this is another sofa that can be moved. Now, let's try again another semicircle sofa, but this time, let's split this into 2 quarter circles, this way, and insert a rectangle, and then carve a hole, and finally come up with a shape similar to a telephone receiver. Then let's try to maneuver this sofa like this, turn the corner, one more time, and we are able to move it to its desired destination. Now, let's analyze the area of this telephone receiver. This was the solution proposed by British mathematician John Hammersley, and that was in 1968. According to him, the area of this telephone receiver is composed of a composite figure. We have here a semicircle, and therefore the area of these 2 quarter circles is also 1.57 square meters. Then in between these 2 quarter circles, we have this rectangle, and according to John Hammersley, the diameter here is 4 over pi, and the height here is 1 unit, and we are going to carve a semicircle to have a hole with a radius of 1/2 4 over pi, or 2 over pi. And therefore, the area of this region in between the 2 quarter circles would be the difference between the area of the rectangle, which is 1 times 4 over pi, which is now this area, minus the area of this quarter circle, which is 1/2 the area of the circle with a radius of 2 over pi. So we have here pi r squared. And simplifying this, we have 2 over pi, or approximately 0.637 square meters. And adding now a sub 1 plus a sub 2, the area of this yellow telephone receiver is about 2.2074 meter squared. Now the question is this the largest possible sofa that can solve this problem? Now, according to this science magazine, John Hammersley did not mathematically prove how he came up with this result. And because of that, this problem is still an open problem for future mathematicians to solve. And in 1992, another mathematician named Joseph Gerver from Rutgers University proposed this solution. Still, this is similar to the shape of this telephone receiver, but Gerver created 18 curves to section these different parts of this receiver. For example, this curve here is number 1. This is the second curve, the next curve, until we go around this shape, and there are 18 curves all in all. And using differential equation, he found out that the area of this sofa is about 2.2195 square meters, which is larger than this 2.2074. But still, nobody was able to prove that this solution is the largest possible sofa, nor this is the shape of that largest possible sofa that can be moved around this L-shaped corridor. That's why until now, this problem is still unsolved. And there are some variations to this problem also. For example, another variation of the problem is this ambidextrous sofa. We want to move this sofa this way, and then move in opposite direction this way. So what is the shape of that sofa. If you are going to use this, there is a problem because we cannot move anymore here. So here is the proposed shape. According to Dan Romick, the shape of that sofa must be like this. And he computed that the area of this has a lower bound of about 1.65 square meters. And let's see if we can move this red sofa in this tight corridor. So let's attempt here. One more turn. It's a success. So let's move one more time here, turn to the right, and move some more. And it was successful. But the problem again is this the optimum shape? And is this the largest possible sofa that can be built in order to solve the problem? But so far, as of now, no one is able to prove mathematically the shape in the largest possible area of the sofa that can solve our sofa problem. And therefore, this problem is still an open problem, and who knows, you might be the one to be able to solve this unsolved math problem. So this is a very simple problem, but still is unsolved. So thank you very much. This is Lando Assistant, and we hope to see you again in our next video. Bye for now.